Hey guys.
Hello.
So since last week, let's see the guys over at Black Magic Design finally released their awesome, epic, amazing device here that we've been waiting on for months and months and months. And what it is, it's a very simple device here that has a Thunderbolt port on it, two HDMI ports, and then this is just a breakout port for doing composite video work. But basically this plugs into our Mac, this plugs into our camera that you're looking out of right now, and instead of recording to an SD card in a compressed format, we record in an uncompressed format right onto the Mac hard drive, the HDMI signal coming out of the camera. And that is a beautiful, beautiful thing.
Yep.
And it matches the Mac Mini very nicely. It's designed from a block of machined aluminum.
Yep. And it's really small too. Like my hand's pretty small, and it's about the length of that. So, fits in the palm of your hand.
So this isn't even available in most of the stores. So you can't really get that. The only store that we were able to find it at is Safe Harbor Computers over in Wisconsin.
Yep.
Friend of the show, Chris Kraft, pointed us over that they finally had it in stock, and we ordered it, and they shipped over within like 2 days or something like that.
Mm-hmm.
They also threw in this, which might come in handy for the road trip. It's a nice foldable keyboard there.
Yeah.
Don't know why they threw it in there, but they did. So that's
Thanks.
nice of them. All right. So that thing also has an HDMI out, so that we can monitor the blocking of the shots on the camera on a big monitor.
Mm-hmm.
And it'll also, I think, be able to let me patch the audio from the recording studio gear directly into the video signal using that breakout cable.
I see.
Because it's got SPDIF audio connections and analog audio connections, composite video and component video connections.
Kind of a hardcore thing there.
Yeah, that's going to be our workhorse in the studio.
Cool.
So this camera will be going on the RoboJib,
Okay.
and the HDMI cable from the camera will be going to that box
Okay.
into the Mac, and then that will combine the audio from our studio grade microphones and the professional video quality out of the camera, and it'll allow us to record directly to the hard drive in uncompressed, ProRes, whatever, or send it directly live out to you guys. So we use Ustream right now, but we're hoping that YouTube will set up this channel to be able to use YouTube Live instead. So the more that you guys rate and comment and subscribe to this channel, the better our chances are of being able to use YouTube for our live feed.
Yes.
And we're getting very close to being able to set up that live feed. So, now's the time to really start making the drive to get the views up on the videos and all that sort of thing.
Cool.
All right, so what are we going to be talking about today on the show?
I think we have XBee, continuation of the XBee tutorial from my side, and I think you are going to be showing them.
Oh yeah, our one of our Twitter followers who is
yes.
an engineer, an audio engineer up in Canada. He works in a recording studio. He was asking about how to use Perfboard for creating guitar effects pedals. So we're going to give a little introduction to solderable Perfboard.
Yep. And I think that's also your H-bridge, soldering up your H-bridge.
A little bit, yeah.
Right. Yeah. So, cool. On to that.
Okay, so you guys have seen this sort of thing before, obviously. It's a breadboard, solderless breadboard, and you can put your components in there and arrange them and figure out your circuit, do all sorts of experimentation on them, and it's sort of a perfect solution for that. You can see this one here. some discoloration on the board. It's because I blew up a capacitor on it. And that sort of thing will happen sometimes when you're working on a circuit and you don't know exactly what it's going to do. So it's better to work on this sort of thing while you're figuring out exactly what you want your circuit to do, or maybe more accurately, how you want it to do it. The next step after this is usually you want to do a prototype that's soldered up. So here we have a little preamp. I need to repair this one. The wire came loose here. So we've got just a couple of components put on this board. And this is Perfboard, solderable Perfboard. It's got a bunch of copper circles on the bottom of it there. And they're the same hole size and spacing as the breadboard. So everything that you know about the breadboard can pretty much be applied here, except you're creating a more permanent circuit. So here's what something like that looks like before you start. It's just this little board, and you've got nothing but your own imagination on the other side, which is, you know, can be a little bit daunting, but I'll show you how you can actually make this do whatever you want pretty easily. The general idea here is you take a project box like this and put your switches or connectors on it however you want, and you can fit your circuit board right in there, attach it with a screw. There's plenty of room in there for a battery, jacks, whatever. And then you've got yourself a nice contained project. So what we're going to do here is show you a few tricks that work on these things. Alright, so here's one of the most important things you need to get down well before you can start, is you really kind of need a good soldering station to work from. This particular unit here has, you can sort of set how hot it's going to get by this. It's not temperature feedback controlled or anything like that, but you can definitely take advantage of the fact that you can keep it cooler or warmer here. There's enough range here to be useful, but if you want a lot more control on your temperature, there's more expensive units that do that. This particular one is a Weller, and the iron plugs right into the side of it here, and you've got your sponge here. Make sure that's wet so that you can clean the tip of your soldering iron as you work. About solder itself, here's how I like to do it. I keep a roll handy in front of me, and I keep a spool of it here inside of a little plant watering device. That keeps me from having to hold the solder in my hand all the time, and it makes it a lot more easy to handle it when I'm working on a circuit. The actual solder I use here for prototyping is a little bit different than what you might see in the store these days, because this is real solder. It has tin, lead, 60. Some of the modern solder does not have lead in it, because we're trying to make sure that we don't use lead in places that we don't absolutely have to, because it is a heavy metal and can be toxic. Now, the prototypes that I make, I'm not sending them to anyone, so I'm not at all worried about the lead issue. So what it does for me is lead melts at a much lower temperature. So my iron does not need to be as hot, and it is a lot easier to deal with than RoHS compliant solder. Now, there's a whole debate around all of this, so do the research, make your own decisions on what is best for you. Alright, I'm gonna get this thing warmed up and we'll actually melt some. Okay, while that's warming up, let's take a look at our helping hands. Now, these things are absolutely invaluable. They allow you to hold wires up to things in a non-moving fashion. and they allow you to hold things that get hot that you would not normally be able to hold in your own fingers. So what you would basically do is attach that there, and your wire there, and then just the tip of it would go through one of the holes, and then this thing will hold it rigidly in place. You've got various adjustments all over it for how rigidly it will hold it, and that'll keep it just where you want it as you heat up the solder and do the work. So today I'm actually working on soldering up the H-bridge, which has been in the last few episodes. Probably not going to finish it today, but I can get some things laid out and started, and that is a much larger circuit than the little preamps that we were looking at earlier, so accordingly I'm using a much larger perf board here for this. The first chip that I need to put in is a let's see, a 14 pin chip, and it's a 7404, and it needs to have a socket so that I can take it back out in case I change the prototype up. I want to be able to use the same chips. So let's get a nice zoomed in look here. So you have to be careful with these, make sure that the legs are square. They don't come that way, and you can get it lined up and put it in your socket, but you really don't want to do that just yet. They can deal with a lot of heat, but we don't want to risk it. We just want to leave them out of the socket and just deal with soldering the socket itself in. So I'm going to go ahead and find a good spot on the board for this, and we'll flip the board around and take a look at it. Okay, I've got my chip set up on the board here. I wanted it dead center in this axis here, and that's because I've got a whole bunch of chips I need to put in a line, and I need room to do wiring on both sides of them. Layout is always a very it's an acquired art, if you will. You just sort of, you do it a couple times and you just sort of get the idea. You learn from your mistakes too. So this time I pretty much already know what I'm doing. I'm working off a layout from John S.A.Z. Now the tricky part on these is that this is loose, and gravity's going to try to hold it back here, make it fall out. So as I solder it, I need to solder one that is not currently out of place. Let's see if I can come in here very carefully and get just the first one in there. Now once it's in, I want to hold my finger against it very tightly and make sure that that's pushed in all the way, because we want that socket to fit very firmly against it. Now you do have to be a little bit careful of when you push. You only push when that solder is liquid. If you push it when it's solid, you'll push that copper pad right up off the board. So here I'm doing the opposite corner, and I'm going to melt it in and push it. Now I know that the socket itself is very squarely against my board there, and the next step there would be to go through and very carefully add solder to each one of the other pins. Alright, I've done a few of these here, and just wanted to let you guys watch here as I did a couple more. The important part here is to make sure you heat the pad and the pin at the same time so that the solder can bond to both, And this is a flux core solder, so it releases the flux. The flux cleans the metal on both the joints, allowing the solder to stick to it. And you can see, once you've done this enough times, it really doesn't take much effort to do so. There, we're done. Okay, so the next component we're gonna get on the board here is a 1K resistor. And we got a couple of these, and we're gonna play some tricks with them. And this is like the good stuff. So what we're gonna want here is get this in the right position. Got 1, 2, 3, and that's where that leg is going. And I want to bend this out, figure out where the other leg is going to come through, bend that down a bit, and get in the right one there. And this is a standard 1mm spacing of holes, and most of the through-hole components are designed to automatically work correctly with it. So as you can see there, it lines up very nicely with the existing stuff there. Now here's where we're going to get into some fun stuff. Let me flip this board over. All right, here we're getting into the real fun stuff. Because the circles aren't actually connected to each other on the back of these boards, you kind of have to make your own traces. And the easiest way to go about this is to just use the existing leads of things like your resistors whenever possible. So here I know that I need to create a pull-up power rail along this section of my circuit. So instead of clipping that resistor lead off, I'm going to bend it over and solder it right in place there. And then the same with this, I'm having to jump over to the other side of the chip because I need to connect to something over here later on. So instead of clipping it off, I'm just going to solder it there. So let's get in here and tack in where the back side of the resistor is. And again, you want to make sure you heat the pad and the lead of the resistor. That allows them to bond together properly. Never use any more solder than you absolutely have to. A little bit on this one. And then to wrap things up here, a little bit back here. There we go. So now we've created two circuit board traces using just the scrap metal off the resistors. You'll find a lot of places in your circuit where you do want to clip them off, and what I do is I just save all of those little clippings so that when I want to create a trace and I don't have a component to work from, I can just take one of my clipped off little leads and put it along the row that I want to connect and just solder it in on each end, and you're good. So that's one of the biggest tricks of the back side of the board. And on the front side, what you want to do is you're working with jumping from point to point there, and this is a breadboard wire, but it's easy to see, so I'll just use that for this demonstration. I'm not going to solder it in. But breadboard wire like that, you can get it shielded or unshielded, and it fits right in there, and you can solder that in to jump over on the top side of the board. Alright, if you guys have any further questions on this Perfboard stuff, let us know, and well, we'll do an update as soon as we have time to fit it in.
Okay, so this week we're going to come back to XBees on our second part of the XBee tutorial. And if you remember, the setup of the actual hardware was that we had an XBee on the USB adapter, and that is connected to the PC, and we're going to be running the X-CTU software from Digi. And the remote XBee is on our propeller BOE board, and it currently has a jumper wire going from D out to D in. So it kind of acts like a feedback loop. You send something here and immediately bounces back to the XBee. So we'll do the same configuration again today. And let's open up a copy of X-CTU. And what we see is that our USB XBee is currently on serial port COM7. So I'm going to do a quick test and query to make sure that we're running okay, and it looks like communication with modem is A-okay. We'll do a range test, make sure that everything looks like it's communicating well with the other remote node, and it looks like everything is lovely. And last week we started with talking about using terminal as just a communication thing where we can type hello world, and we can see that in each time we send a letter, we get back a letter because the ping time is extremely fast. But now we can use terminal as a kind of a DOS window, a way to change the commands and change some of the properties of the XBee. So in order to get into command mode, you type out some data, wait a few seconds, and then press positive, 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 or plus, 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 and it says OK, and you end up going into command mode. Now the thing about command mode is that it only lasts a short amount of time, so actually in the amount of time that I'm talking, we're probably already taken out of command mode. But just to let you know, when you start changing these properties, you have to work relatively quick. So the first thing that we're going to go into is changing channels. Well, first looking at what channels we're on, and then changing the channel. And the channel is just pretty much the frequency that the XBee is currently working on. I believe these XBees have, 12 different channels that it can talk on, and that's like 12 different frequencies, or if it's easier for you to understand, like 12 radio stations. So I'm going to go ahead and get back into the command mode. Okay. All right, I'm going to request the channel that we're currently on, and we're currently talking on this XBee on channel C. And now I'm going to change this to channel D. That says OK. And we're going to wait to leave the command mode. And there is a command for this, ATCN, but I'll show that in just a little bit. Okay. And when I type out hello world, you see that we don't get anything back because now they're kind of talking past each other. So this XBee is sending on channel D instead of channel C. I'm going to go ahead and change it back. And you can change it back by either saying ATCHC, or you can do ATRE, which is to restore the defaults. Okay, and let's leave the command mode with ATCN. So you have sometimes when you're changing things and you're trying to test to see if you get a ping back, you're not quite out of command mode yet. So remember to close out of command mode with ATCN before you test the ping. And there we go, testing the ping, and it looks great. Okay, and now XBees can be part of these very large networks. And so in order to be able to talk to a specific node, even when you're physically next to another XBee, what you can do is change the identity of yourself, of your base node, or you can change the identity of the remote node. So let's go ahead and clear the screen. And what we'll do is, okay. So the default my source which is the source identity, and the default destination addresses for these XBees are 0 and 0. So my address is 0, the destination address is 0. And this goes the same for the remote node. Now, say I want to change change my identity, the base node's identity to 1. What that means is that because the other node, the remote node, is talking to address 0, we actually won't see any feedback. So I'm going to go ahead and do that. ATMY, and we'll change it to 1. Okay, I'm going to close out of the command mode. And now I'm going to test to see and make sure that we're not getting anything back. And what you see is that because I've changed the address of the base node to 1, the remote node can no longer talk to it because it's trying to get to address 0. So let's go back into command mode. And then I'm going to go ahead and change my base node back to 1, or back to 0, sorry. Leave command mode. And now, when I type in hello world, you'll see that the addressing is proper. Everything works according to what it should. And we can also change the destination address. So currently, the destination address of the XBee, the remote XBee, is 0, right? Because that's default. So if I change it so that my base node talks to an address of 1, theoretically, we should see that there's no communication between these two XBees. So let's go ahead and do that. Got into command mode, ATDL, destination address of 1. Okay, we're going to leave the command mode. And now when I do hello world, whoops, hello world, we see that there's nothing that comes back. So, we changed what destination, where I'm sending the goods to, and we see that we're not obviously talking to anybody. I'll go ahead and change that back. ATDL0, ATCN for getting out of the command mode. And then we do hello world. And it works. Lovely. Now sometimes if you want to broadcast from a node, so say regardless of what the addresses are, you want everybody to hear what you have to say. So you can change the destination to FFFF, which means broadcast to all. So if I go into command mode, ATDL, see, now this is where I did my mistake. I didn't get out of command mode. So getting out of command mode, there we go. So if you remember, I said that sometimes you can get stuck in command mode for a little longer than what you're actually able, you can just get stuck in it, and how you have to close out. Otherwise, what you send will look like a command. So this has happened to me a couple times, but here, just showing you that you gotta close out. And then when you test, you'll see that it's talking on all channels, and you can get back your feedback. So I'm going to clear the screen here. We're going to go back into command mode, and we're going to restore with ATRE all of the defaults. And so right now, the my address is 0, the DL address is 0, and everything is as it should be. So let's see, we have gone through AT, the plus to get into command mode, ATCH for the channel, ATMY for the source identity, ATDL, ATDL FFFF, ATCN for the leaving the command mode, ATRE that we just went through here for restoring the defaults. And let's go into labeling your nodes. Okay, So sometimes you can label your nodes with different names. Now, you won't exactly be able to see it on this example that I'm doing because I'm labeling the USB node instead of the remote node. And there's a way for you to ping remote nodes to see what kind of information you're going to get from them. But for now, I'll just show you how to do it. Okay, so we'll do a quick hello world. Wait a few seconds. All right, get into command mode. Now, ATNI is the command to name something. So right now, my base node is now named node 1. You can do ATNI base node. That might be easier to understand. Okay, and because I can't really demonstrate how that looks. I'll just, oops. There we go. I'll just go back to restore defaults. Now, I also mentioned that we can look and see what the other nodes are, and that's called node discovery, and so that's with the command ATND. And I think we're probably have to go back in. Wait a few seconds, +++ for the command mode, and we do ATND. Okay, and so what this shows is it's pinging all of the other remote nodes and giving us a bit of information. First, what their my address is, and therefore what you would be DLing to, what your destination address would be to. It gives you their serial number, gives you their noun name. So if I had changed the noun name of the remote node, this would say remote node. And then it also gives an RSSI level. And RSSI is the receiver signal strength indicator level. It's what we had that colored bar in the range test before. And this is done in hexadecimal. So what you do is you take that hexadecimal letter number combination, change it into a number, add a negative sign to it. And if you remember, -40 was better. And I think 100 is worse. So I believe, do you know off the top of your head what 1C is, Whisker?
A is 10, B is 11, C is 12.
Okay.
So 1 is 16 plus C, which is 12.
So that's 28. So -28. So somehow we're so amazing that our RSSI level is like even off the charts. So awesome. But that's also because they're like right next to each other. So that tells you this ATND is really useful for letting you know what all of your other nodes are. Okay. And let's see. We can talk about the signal strength. So I'm just gonna, oh, see, that doesn't work either. Okay. I'm gonna wait a little bit. All right, we're back in command mode. I'm gonna go ahead and just type ATDB. And all this does is it gives us the signal strength, and like before it was 1C, now to, it just gives us that one measurement. I think I will skip the personal area network ID and the frequency channel for next week because I think I'm probably running on a little long. So until next week. Yeah.
All right. Thanks for explaining all that stuff, Addie.
You bet.
Doing a pretty good job with that. And another friend of ours, SciGuy14 on YouTube, has also done some pretty awesome tutorials with this kind of stuff.
Correcto.
So let's get to the close, shall we?
Okay.
Bum, bum, bum.
Okay, so you guys wanted me to get a better cutting utensil, and so I decided to upgrade to the new and awesome Nurse Scissors 2.
Bring that closer.
How much closer?
Oh, those are nice.
Yes.
That is like stainless steel.
Yeah, I know, and it's even better.
I don't think that's going to convince people that you shouldn't use a box cutter, but those are some sexy scissors.
Now in more glory.
Look at the hook on those.
I know.
That's a thing of beauty.
Yeah, it's kind of sharp,
wow.
actually. So, we have another unboxing to do today. Huzzah!
Yeah, well, we should give them some context.
Okay.
We have been talking about the road trip. We're going on a bit of a tour. 12 cities in 12 days.
Yeah. 12 states in 12 days.
Oh, yeah. Yeah, well, 12 states.
12 cities is too little.
Yeah, a lot more cities than that. But
yeah.
So we're going to be meeting a lot of people on the road.
Mm-hmm.
And hanging out with people at Parallax and stuff. But after Parallax, we're going to be stopping in lovely San Francisco.
San Francisco.
And
oh crap, peanuts.
While we're there, we're going to be hanging out with our buddy Joe Grant. And we're going to be doing some video and audio production on the road while we're doing it. And we need to build a mobile
nuts and bolts. Yes.
A mobile production rig.
This is your hat now, Whisker.
I see.
Every nerd should have a nuts and bolts hat. Here,
okay.
You can wear it.
I've been reading that magazine since I was like a teenager. Okay, so we need to be able to produce video on the road.
Yeah.
And we're building a mobile rack to do so. And Joe designed a product a while back using an LCD module that he thought might come in valuable. Well, the parts out of the inside of it might come in useful.
What is this?
I don't know.
Quick Stick. From Freescale. Oh, there's
Oh.
a CD in there. But what is it? What does it do?
Bet you that's a little dev thing.
Yeah, it seems like it.
We'll have to look into the details on that.
And it's orange!
You're holding everything a little bit high, by the way.
Oh, sorry.
Yeah, there you go.
There you go. And it's orange. I love orange. All
So,
right,
I know Eddie keeps interrupting, but I'm sure you guys are all clever enough to follow along. We're going to get to the big stuff in the box here. And Joe had an LCD module. I'm guessing that's something else. Let me take a look here.
Oh! This is great.
What is that?
This is Nova, which we like their ending music, of course.
Nova.
Yeah, Nova. But the best part is that it's KGB, the computer, and me. How very hackerish. Now the problem is we don't have a VCR, so I'm not quite sure how we're gonna play this. But I imagine it's somewhere on the intertubes that we'll legally find.
For those of you who don't know, Joe is a rather well-known hacker from back in the day. So
it's like Whisker's idol, man. All right, I think that's what we got. And peanuts. Oh wait, no, we have something else. Oh my gosh.
yeah, there's gonna be the
Tricky.
big part in there.
Tricky. Okay, well, what is this?
Joe's just like cleaning out his closet here.
Oh, that's cool. All right, is this perhaps it? Whisker? This might be it. You think?
Maybe.
I mean, what? You're dumping all the peanuts on the floor.
Yeah, well, that's fun. Making a big mess
Yeah,
here,
but
guys.
I gotta clean up. Oh, there's something else here too. Oh my gosh. Is it a picture? Is it a signed autograph?
I would imagine that that's the LCD module that's going into the road case.
Yes.
Check
it's
that out.
It's that
That is a raw LCD module.
Oh, this is very
Hold
nice.
it lower so everybody
Okay.
can see, not just you.
Right, so it's, let me see if I can take this out too. Oh, this is very nice. See? Whisker.
Hmm. Yeah, that should fit in a rack drawer pretty nicely.
Perfectly.
So we're going to be doing a whole lot of project video on the design of our rack drawer. And that is a nice thin little starting point for the monitor.
Beautiful. Thank you, Joe. That's to be kind of cool, kind of super hackerish for me, because you know when people say they build their computers, it really just means that they're hooking up components together, not really actually building. But this feels like it's actually building.
Can I borrow your scissors for a second there, please?
Yes. Please be careful. They're very dangerous.
Nursing may happen.
Nursing may happen. Oh, bubble wrap.
So, in that unit that Addie handed over to me here is the, here, could you show them this? This is actually the control board for that LCD module. And if you look here in the end,
what am I supposed
on the
to
end,
oh. You're actually pushing it so people could see.
yeah,
I see.
it's not VGA, it's USB.
Sweet.
So
it's a USB screen.
interesting.
Joe was ahead of his time, I gotta say, because they're starting to come out with USB powered like screens instead of, so you don't have to go with this big bulky thing. You can just go with this nice little flat. What is it? Field. We'll have to find out what it's called. But
So let's be clear, Joe designed that board. So, you know, we've got cool friends.
yes.
All right, I think that should be everything that's in there.
Yes. Thanks for
There
the
was some
hack,
other
the
stuff in
video.
there, but we're definitely not going to show you guys that.
Right. And thanks for the video and the amazing LCD screen.
Joe was sending things like, you know, a 12-month calendar of himself
And the Speedo.
in Speedos, yeah.
We'll be sending ourselves to you in a couple months.
All right.
Yeah, by ground. So,
Well, I think that sums it up for today's epically long show. Thanks for watching. Make sure you guys subscribe, and we'll be back next Wednesday with another show.
yes. Bye.
Bye.
We post videos all the time, so don't forget to subscribe. And follow us on Twitter at TYMKRS.